Okay, in this video, I'll be looking at acceleration time graphs. In my previous videos, I just looked at displacement time graphs and velocity time graphs. I've done a whole heap of videos in Kinematics, so if you haven't checked out my playlist, please do so. And if you already haven't subscribed, please subscribe. So let's have a look at acceleration time graphs. We just read acceleration or times directly from the graph if the questions are requiring that. The area under the graph is to find the change in velocity of the object or the total distance traveled. Now, because it's a vector quantity acceleration it needs a magnitude and direction. So it's given to us on the y-axis. Now let's have a look at a typical exam question. Now, if you're seeing instantaneous on the screen and you haven't seen that word before, I've done a whole video on that in my previous videos in the playlist, so please check it out. But instantaneous just means at that very moment of time. So let's have a look at this table and see if we can answer it. Now, if you're looking at this graph, it's a typical acceleration time graph. So you've got here acceleration on the vertical axis and time on the horizontal axis. So let's have a look here. It's asking us for the instantaneous acceleration at 3, 6, 8, 13, 17, 20, and 21 seconds. So you can see here, just by reading off the graph, you're going to get 12 west for 3 seconds, 6 west for 6 seconds, and then at 8 seconds, it's 0. And that's just reading from the graph. 13 seconds, it's at 12 meters per second east. At 17, it's 6 meters per second east. And then at 20 seconds, it's 12 meters per second west. And at 21, it's just 18 meters per second west. Okay, so that's pretty straightforward. Now, if instantaneous velocity, we just need to state the velocity at that very moment of time. So we're looking at area. Okay, so you've got 36 meters per second west for the first answer. For 6 seconds, you've got 60 meters per second west. For 8 seconds, it's just 72 meters per second west. For 13, it's 36 meters per second west. For 17, it's just 9 meters per second east, and 20 seconds is 0, and at 21 seconds, it's 15 meters per second west. So we're just working out the area of which that has traveled in. So for the first one, 3 seconds for instantaneous velocity, it's minus 12 times 3 will give you 36, and direction is west because it's below the 0 line. And you just do that for each. Okay, so it's just the area that it's traveled in. Okay, now let's have a look here at this question B. Determine the change in velocity of the object between 4 seconds and 12 seconds. Now, if you look here, I've got an answer that's pretty surprising. That's 0. And you can see that both of these areas cancel out. And it's because they are equal on opposite sides of that 0. So you just get 0. C. Determine the change in velocity of the object between 4 seconds to 18 seconds. Now, the answer is 60 meters per second east, but how to work that out? Now, if you look at my video here, I've got 2 x's, and this is why it's 0 for B. It's those 2 x's cancel each other out, so there's no point working that out for the area because they equal 0. So we're left with the remainder of the blue underneath the graph. So if you've got the blue underneath, you can see that basic arithmetic is 12 to 16 is 4 seconds over 12 meters per second is acceleration per second. So it's 4 times 12, which is 48. And then the remainder of that triangle, which will give you the difference of 12 meters per second. So basically 48 plus 12, which is the square, which is 48, 12, which is the triangle, and you'll get 60 meters per second east because it's above the 0. Okay, so it's pretty straightforward. I hope you enjoyed this video and I was pretty clear on how to answer acceleration time graphs.